Welcome back. We're going to talk about some advanced objects concepts. Now, as I said, with both arrays and functions, these are advanced concepts. You're probably not going to just get it 100% the first time around, but use these videos as a reference to come back as you progress through your career. Now, in this video, I'm going to talk about three things that are important with objects. We're going to talk about reference type. We're going to talk about context. And finally, we're going to talk about instantiation. So let's get started with the first one, reference type. What do I mean when I say reference type? Well, I want you to see if you can guess what's going to happen when I do array equals array. What do you think the answer is going to be? Let's see. Interesting. Okay, what if I do array1 equals array1? Interesting. Okay, one more question. What about something like this? Object1 equals a value of 10. And we'll say object2 equals object1. And we'll finally say variable object3 equals value 10. So looking at these, and I'm actually going to copy it on here so you can see it as well. Looking at this, what happens if I do object1 equals object2? What do you think will happen? True. Okay, that makes sense. I mean, object2 is object1. But what if I do object1 equals object3? Here I get false. But why is that? We have value 10, they're both the same thing, right? Let's check something else. What if I do object1.value equals 15? Okay, and now I do object2.value. It equals 15, but if I do object3.value, I get 10. Well, that was confusing, right? Let's look at what's actually going on. And this is the first topic we're talking about, which is reference type. Let's look at a diagram. Objects are what's called the reference types in JavaScript. Up until this point, all the other JavaScript types that we've learned, including numbers, null, we have undefined, booleans, strings, even symbols, they're all defined by the programming language. So JavaScript, the person who wrote JavaScript, and ECMAScript, the standard, says these are primitive types. We tell you what they are. Now, a reference type, which is a non-primitive type, are not defined by the programming languages. What that means is that they're created by the programmer. So let's look over here as an example. When I say variable number1 equals 1, JavaScript knows what 1 is. It's a number, and it's a primitive type. It's always the same thing. It's immutable. Every time it uses a 1, that's the same one that JavaScript knows about. When I do variable number2, it's using the same number1 that JavaScript knows about. However, when we created object1 equals value 10, and object2 equals object1, and object3 equals value 10, well, those were created by the programmer. They're reference types. So what we said was, I want object1, create a new object. We'll say this box over here, this filing cabinet, and in it, put value 10 into this box. Object 2 says, I want you to just reference, and that's where the word comes from, reference object 1, saying, hey, I want whatever's inside this box. When object 3 gets created, it's a new object because we have the new brackets, and it's saying put value 10 in this box. Essentially what we're doing is saying, when we create variable object 1, we're storing just a reference, an address to where we're storing the value 10, which is box 1. So we're saying object 1, I'm just letting you know that this is the address of all the contents that you want. And that's in box 1. Object 2 is saying, I want whatever is in object 1, and we look in object 1, and object 1 just has the information of box 1. So it references that. And object 3 creates a new object, so it's saying, I'm going to put my contents in box 3, and I'm just going to have the address of the box saying box 3. That's right over here. So going back to our example, this makes sense. When we change object 1 value to 15, we change the contents of box 1. So when we do object 2 dot value, which is referencing the same box as object 1, that's 15. But object 3 dot value doesn't change because that's interested in a completely different box. It's box 3. And going back to the first example, arrays, well, as I mentioned in previous videos, arrays are just objects at the end of the day. So when you create an array, it's the same thing, creating a box, a data structure, and this is creating a second data structure. All right, so that is reference type. A very important concept, but I think you get it, right? Let's get to the next one. This gets a little trickier. This one's called context. And context gets confused a lot with scope. If you remember, we said that scope is created when it sees curly brackets, right? We said that if we create a function, as soon as we create that function, there's a new scope that's created. So we can have let A equals A, and that lives within this universe. It doesn't know anything about the root scope, which is over here. So if I do console.log A, well, it's not going to work. Oh, and we need to actually assign something, and we need to name it. So let's just say B. So if I do this, well, console.log A will just return reference error because it doesn't exist. So that's scope. Now, how is context different? Context tells you where we are within the object. Let me explain. If we say console.log this, well, you see, I get some highlighting. And this is the first time we're seeing this. And it's a special word in JavaScript, probably the most confusing word that a lot of people have trouble in. Even people that have been in the industry for years still have a difficult time with this. But let's see what it is. This is, as you can see, the window object. So just to double check, if I do console.log this equals window, I get true. And I can access this dot alert hello. So what this means is, what is the object environment that we're in right now? The best way to think about it is, what is to the left of the dot? So right now I'm able to do alert because I'm inside the window object. So doing window or doing this is the same thing. Now, why is that important? Well, when we get to instantiation, I'll show you why it is, but it's a very important concept that you'll see again and again. But remember, this just refers to what object it's inside of. Two more examples to demonstrate this. One is if I do function A, within function A, we'll say console.log this. So if I call A, what do you think happens? Let's see. Still the window object. This still refers to the function. And if you remember, that's because I said it has to be what object we're inside of right now. Technically, function A, I can go window.a and run the function. So to the left of the dot, well, that's the window. In order to create a new value for this, you have to do something like this. Object A, function A. Now if I do function, and within here I do console.log this, well, in that case, if I copy this and run object for.a, well, now this is the object, which is object 4. So why is that important to us? Well, first of all, you'll see it in other code bases, so it's good to know. But it's really important when we do instantiation. Instantiation is when you make a copy of an object and reuse the code. Imagine you're building a big multiplayer game online. And this game's going to have many, many players. You can have wizards, you can have trolls, warlocks, elves. Now, if you had to create an object for every single player, that's a lot of repeated code, that's a lot of hassle, and well, that's a lot of your time, and it's not very efficient. To solve that, you can do something called instantiation. You're making instances or multiple copies of an object. So let me show you how we do instantiation in JavaScript. Again, this is going to look a little bit weird at first, just like for loops did, just like functions did at the beginning, but it's just the syntax and you'll get used to it. So let's say we have a player class. Now you see the new syntax already, and I capitalize a class. Now think of a class as something that I want to make a copy of. If I ever want to make a copy of an object, it's a good idea to do something like this so that, well, you'll see how easy it is to copy this now. So we do class player, and within here, we'll say constructor. And I know this looks weird, but again, it's just syntax. Let's give it, this player can have a name and a type. And within the constructor, this.name equals name. And this.type equals type. Oh boy, what just happened here? Constructor, when you create a class, a player class, says, every time I'm making a copy of a player, the first thing that gets run is the constructor function. And this constructor function is going to create these properties on the player object. So name and a type. And now I can create anything that I want for the player. Let's say we want to create a method such as introduce that console.logs with backticks, hi, I am. And again, we remember the syntax, template strings. This.name, I'm a this.type. Awesome. So now I'm saying this player class any player that I create will always be able to introduce himself. And they'll also have this name and this .type. And the reason we use this here is that when we create a player, we can access the name and type property. I'll show you later on how that works, but this is just a syntax you're going to get used to. In order to access the player and make copies of it, you'll have to run a constructor, which is all the properties and methods that you want the player to have. You can also create methods that players can have. And anytime you want to access a property within the constructor, we'll use this .name. If I want to use introduce, I'll have to do this .introduce. Okay, so we have a player, but when we're building our multiplayer game, we want to now copy this but add on to it. Let's say we want to create a wizard player, a player that's a wizard. In that case, we would do class wizard, again, capital letter, extends, and again, it's just a JavaScript keyword, player. So what is this saying? I'm saying I want wizard to extend whatever player has. So I want to add on top of whatever player has. Again, because it's a class, we'll have to do a constructor. And this wizard is going to accept name and type. And within here, this is the tricky part. Anytime we extend something, we need to also call the constructor function of the player. We have to do something called super with the properties that we want to pass to the constructor. In this case, name and type. I know this is confusing. It's just something you have to do. Whenever you extend a class, you want to use super so that you essentially have access to these. Okay, so let's say that with the wizard, we also want to have a play function. And the play function will just console.log I'm a this type. And now that we have our wizard, what's the power? What's the reason that we just did this? Now we can do this. Instead of constantly creating players and then saying that they are wizards and they can play, now I can say wizard1 equals new wizard, and we'll call the first wizard, again, we get name and type. So we'll say Shelly, and she'll be a healer. And if I want to create a new wizard, I'll just say wizard2 equals new wizard, Sean, and he is dark magic. Whew, that was a lot of new syntax. So let's go through it and make sure we understand everything. As we've learned, let's use console log to really understand what we're doing. I'm going to add a console log right at the top over here. And we'll say this. What is this? I'm going to save. And actually, I'm going to copy this into the console. Let's copy it and see what the console log gives us. We see that we get wizard. All right, let's go through everything here. I say we have a class player, then a class wizard that extends player, and then we have two variables that we created, wizard1 and wizard2. Now, the program is going to see the new keyword, and anytime it sees the new keyword, it says, oh, we're creating a new wizard. And this wizard is going to have two parameters, Shelly and healer. So it's going to go to the wizard class. Again, because it has this new word, it goes to the wizard class and it says, hey, wizard, I want you to extend player. So it's going to go to the constructor and it's going to see this super. And what this does is it takes us up to the constructor of the player and it runs this. And now it attaches this as the wizard. And then it introduces the new function and then adds the play function. Now, if I go to wizard1 and I say play, I get I'm a healer because Shelly's a healer. But I also have access to wizard1 dot introduce. Hi, I am Shelly. I'm a healer. And we also have access to wizard2. Oh, I have to run this again. Let's run this again. And I don't think I copied the second wizard last time. So now I have wizard2 introduce. Hi, I'm Sean. I'm a dark magic. That sentence doesn't make sense, Sean, but that's okay for now. Let's just try something. If I do console log here, and we'll just say wizard, and here we'll say player just so we can distinguish between them. And I'm only going to copy the first wizard so that we don't get two of these running. Again, because we're creating two wizards, we're going to have this run twice. But just for our sanity, we'll run Shelly. So I'm going to refresh and add here. Oh, I forgot to add a comma. And let's refresh. And I get an error. Reference error, must call superconstructor and derived class before accessing this. What that's saying is that in order for me to access this and get this.type, I have to call super, which runs a construction function in player. So that's what super is doing. It sounds kind of weird, but it's just something that you need. I'm just going to put this at the bottom after we call super. And now it should work. Let's see. I get the first player, wizard. So we call super. As soon as we say new wizard, Shelly healer, I go to the wizard extends player. I run the constructor function, which says super. Hey, run the constructor function in the player. And I run that. And that's why we log console log player first. And then we go to console.log wizard and then run the rest of the class. Very cool. Now, just to show you something, this is actually new syntax that you'll see in React, and it was part of ES6. But back in the day, this is how we used to do it. The exact same code I have up there is right here. It's called classical inheritance, and it doesn't look too bad, but you see that there's prototype, which it's another thing that you'll see in JavaScript, and to be honest with you, you shouldn't really use it. It doesn't look very nice. And you see that we have to attach play to both wizard1 and wizard2, and it just doesn't look as nice as this. And once you get used to everything, it's not too bad. All we're saying is, as soon as we say class, we say, hey, we're probably going to make a copy of this object. So we want to make copies of player, we want to make copies of wizard, and that's called instantiation. When I do the new keyword, I say, make an instance of wizard. And wizard uses some functionality from the player and adds its own little play function as well. Holy moly, that was a lot. Like I said, this is something that you'll have to come back to, and you won't get it right away. It's really hard to fully understand the topic without actually having to use it in real life. Just keep this in mind. Every time you hear somebody talk about reference type or context or even scope or instantiating something, well, these are the things that they're talking about. Objects are really complicated. They're really hard, but with that, it gives us a lot of power. So with that, good luck with the exercises. I'll see you in the next one. Bye-bye.